Welcome to today's explainer. All right, let's just dive right into this. Have you ever actually stopped to wonder how the price of, well, basically everything around us gets decided? I mean, from the coffee you grab in the morning to that incredibly complex smartphone sitting in your pocket right now. It can kind of feel like magic, right? But it's not. It's actually driven by these powerful, invisible market forces that act, well, remarkably like the laws of gravity. So today, we're going to visually map out these forces together and uncover the exact geometry of how markets find their perfect balance. Just think about it for a second. Neither you as a single buyer nor a single shop owner as a seller gets to just point a finger and dictate the market price. It doesn't work that way. Instead, it's this beautiful synthesis. As our source points out, millions of independent and, let's be honest, often selfish choices by buyers and sellers just magically interact to create a single, incredibly stable market price. But to really understand how that happens, we first need to define exactly what we're aiming for. And that ultimate goal? It's called equilibrium. As the definition here lays out, equilibrium is that perfect, almost fleeting situation where the exact quantity of a commodity that consumers want to buy perfectly matches the quantity that producers want to sell. Basically, there are zero leftovers and absolutely no one is left waiting in line. And the specific price where this magical alignment happens, we call that our equilibrium price. So with that foundational vocabulary locked in, let's actually build the visual system that makes all of this super easy to see.
Section 1. Finding market balance, the foundation.
Okay, to see how this works, I want you to picture a blank graph in your mind. On the vertical y-axis, we're measuring price. On the horizontal x-axis, we're measuring quantity. Step 1, we plot our market demand curve, and we'll just call that DD. This line slopes downward, because, as things get cheaper, people naturally want to buy more of them. Step 2, we plot our market supply curve, SS. Now this one slopes upward, because as prices rise, sellers are going to want to produce and sell a whole lot more to rake in those higher profits. And then step 3, which is absolutely crucial, we mark the exact spot where these two totally opposing forces cross paths. That's our intersection point E. So, when we actually bring those forces together, it looks like this. You can clearly see the downward-sloping DD curve and the upward-sloping SS curve meeting right dead in the middle at point E. By drawing a straight line from point E over to the y-axis, boom, we establish our equilibrium price, which is labeled OP. And by drawing a line straight down to the x-axis, we get our equilibrium quantity, labeled OQ. The major takeaway here is that at price OP, everything is just in perfect harmony. The precise amount that sellers are willing to supply, OQ, is exactly the amount buyers are willing to purchase. Nobody has excess inventory gathering dust in a back room, and no consumer is going home empty-handed. Think of it like a bakery selling its very last warm croissant to the very last customer in line exactly as they flip the open sign to closed. It is a state of absolute, perfect stability. Section 2. Unpacking excess supply. The gravity of surplus. But hey, we all know the real world is messy, right? Perfect harmony rarely lasts forever. So what happens to our perfectly balanced system if the price doesn't just stay at OP, but instead gets pushed artificially high, all the way up to a new price line we'll call OP1? Well, buckle up because we are about to witness a super fast transition from perfect stability to absolute market chaos. Notice that upper horizontal line on the graph, the one labeled P1? At this artificially high price, our demand curve and our supply curve, they are no longer touching. Not even close. Instead, we're looking at a massive gap between point A on the demand curve and point B on the supply curve. The market is officially broken. Let's actually translate those geometric points into real human behavior. At this sky-high price, a lot of everyday consumers who could afford the original OP price are simply priced out. They take one look at the price tag, say, "No way," and walk away. So the quantity demanded shrinks drastically down to P1A. But on the flip side, sellers see these high prices and they're just seeing dollar signs. They eagerly ramp up production to cash in, expanding the quantity supplied all the way out to P1B. And this mismatch creates a massive surplus, which our source material officially calls excess supply. Geometrically, it's perfectly represented by that segment AB on the graph. Now, I want you to think about this excess supply literally like gravity. Sellers are suddenly stuck with massive warehouses full of unsold stock. To just survive, they have to put everything on the clearance rack, aggressively slashing prices to attract whatever consumers are actually left. This natural, desperate self-correction pulls the price forcefully downward, escaping the OP1 price and heading right back down to our stable OP. Section 3. Unpacking excess demand, the upward push of shortages. Okay, now let's flip the entire script. What if, instead of being way too high, the price drastically plummets to a crazy bargain basement level? Let's trace a brand new low price line on our graph, which we'll call OP2. Down at this low price line, starting at P2, we have a severe disconnect once again. Our supply and demand curves are absolutely miles apart, creating a huge gap between point K on the supply side and point L over on the demand side. So here's the human element of this low price scenario. Because the price is an absolute steal, new buyers just flood into the market. Quantity demanded balloons all the way out to P2L. I mean, think of people pitching tents and lining up around the block for a crazy Black Friday TV sale. But producers, they completely lose all incentive to make the product because they can't even cover their costs, let alone make a profit. So the actual quantity they supply drops all the way back to P2K. This massive gap, segment KL, represents excess demand, which most of us just know as a shortage. And what does a shortage do? It sparks an intense bidding war. Think of superfans desperately trying to get front row concert tickets. Consumers who really want the limited goods start outbidding each other, literally offering to pay a little bit more just to make sure they get what they want. This intense, cutthroat competition among buyers provides a massive upward thrust, pushing prices higher and higher until they escape OP2 and climb right back up to OP. Section 4. The resolution. A stable equilibrium. Taking one last look at our full diagram, we can really synthesize these two totally opposing scenarios. The true, undeniable genius of the market mechanism reveals itself right here. Point E isn't just a random intersection. It is an inescapable center of gravity. No matter how far the market is temporarily displaced, whether that's up to P1 or way down to P2, the underlying forces of human behavior will always drag it kicking and screaming back to this singular, stable equilibrium point. Just to quickly summarize the sheer mechanical logic we've uncovered today, high prices at OP1 create a surplus, that's segment AB, which inevitably pulls prices back down. Low prices at OP2 create a shortage, segment KL, which inevitably pushes prices back up. The equilibrium price OP naturally and constantly restores itself through the totally free interaction of buyers and sellers. It's a remarkably self-healing system. But, all this leaves us with a truly fascinating and honestly pretty provocative final thought. If these market forces always perfectly self-correct back to point E, what in the world happens when an outside force, like, say, a government, steps in and legally bans prices from ever reaching that equilibrium? When governments impose things like strict price ceilings or price floors, they effectively break this perfect geometry. But exactly how much chaos does that cause? Well, that is a fantastic question, and it's exactly what we'll dive into in our next explainer. Thanks so much for joining me today, and keep questioning the invisible forces around you.